Must know number 1. What is a fraction? A fraction is a way of expressing parts of a whole. And then a fraction looks like this, where we draw a horizontal line, which represents a division operator. And then above the horizontal line goes a number which we call the numerator of the fraction. And below the horizontal line goes a number which we call the denominator of the fraction. Now, the denominator actually represents the total number of equal parts that the whole is divided into. And the numerator represents the number of parts of the whole that are being considered. So let's try an example now where we will create a fraction. The example says, what fraction of the shape is shaded? Well, I see that I have a square that has been divided into 4 equal sections. And of those 4 equal sections, I see that 3 of them have been shaded in. So to represent this as a fraction, I'll draw my horizontal line. And then in the denominator, since the square has been divided into a total of 4 equal parts, I'll write a 4. And then since we're considering what fraction of the shape is shaded, in the numerator will be the number of parts that are shaded in. And I see 3 of them are shaded in, so 3 goes in the numerator. So our answer is 3 over 4, which can be read as 3/4. And we interpret it to mean that 3 out of the 4 parts of the square are shaded. Must know number 2, reducing fractions. Reducing a fraction involves simplifying it to the form where the numerator and denominator are as small as possible, but still maintain the same proportional relationship. So before I teach you how to reduce fractions, let me show you why 1 over 2 is the equivalent but reduced version of 2 over 4. Now let me try and give you a visual representation of both of these fractions. So for each of the fractions, notice that I drew rectangles of equal size, but in this rectangle, I divided it into 2 equal parts and then shaded in one of those 2 equal parts. But for this rectangle, I divided it into 4 equal parts and then shaded in 2 of those 4 equal parts. And hopefully you can see that if I were to move these rectangles, so they're right on top of each other, that the exact same proportion of each of those rectangles have been shaded in, which should tell you that the fraction 1 over 2 is equivalent to the fraction 2 over 4. But this fraction, the numerator and denominator, the numbers are smaller. This is the reduced but equivalent version of 2 over 4. And now let me show you a couple different methods for how you can reduce fractions. So I'll get rid of this demonstration. Let's look at how we can reduce the fraction 24 over 36 using 2 different methods. Method 1 is the greatest common factor method, and method 2 is the prime factorization method. Let's start with method 1, the greatest common factor method. For this method, we just have to divide both the numerator and denominator by the biggest factor that they have in common. So let's make lists of the factors of both 24 and 36. Now, in those 2 lists, we just have to find what is the biggest number that those lists have in common. 12 is the biggest number that divides evenly into both 24 and 36. So then what we do is divide both the numerator and denominator by 12. Now let me move this over so I have a little bit of room to write my reduced but equivalent version of this fraction. 24 over 36 would be equal to, well, 24 divided by 12 is 2. And 36 divided by 12 is 3. So the fractions 24 over 36 and 2 over 3 represent the same proportion. They have the exact same value. Just 2/3 is the reduced version of 24 over 36. And now let me show you how we can get that same reduced answer using method 2, which is prime factorization. So I'll move this over a bit so I have room to actually rewrite both the numerator and denominator as products of their prime factors. Starting with the 24 that's in the numerator, I could write it as a product of the factors 2 and 12. Now, those aren't the prime factors. 2 is prime because the only numbers that divide evenly into 2 are 1 and itself, but 12 is not prime. So let me rewrite this 12 as a product of the factors 3 and 4. Now, 3 is a prime factor because the only numbers that divide evenly into 3 are 1 and 3. But 4 is not a prime factor. 4 could be written as a product of the factors 2 and 2. And now this is the complete prime factorization of 24. It's a product of only prime numbers. Now let's find the prime factors of 36. I could start by writing 36 as a product of 3 and 12. 3 is prime, but 12 is not prime. So I'll break 12 up into a product of 3 and 4. And then 4 is not prime, so I'll break that into a product of 2 times 2. And here's the full prime factorization of 36. And now what we look to do, are there any factors in the numerator that can cancel out with any factors in the denominator? Well, I have a 3 being divided by 3, that's 1, so I can cancel those factors. 2 divided by 2 is 1, so I can cancel those factors. And same with this pair of 2's. So notice all we have left in the numerator is 2, and all that we have left in the denominator is 3. So this fraction would equal 2 over 3, which is the exact same answer that we got using the greatest common factor method. Must know number 3, multiplying fractions. The rule for multiplying fractions is that if you have the fraction a over b being multiplied by the fraction c over d, the product of those fractions would just equal a times c over b times d. So simply put, when multiplying fractions, you multiply the numerators a times c, that becomes the numerator of your product, and then you multiply the denominators b times d, and that becomes the denominator of your product. And then let's do some examples of multiplying fractions. And there are actually 2 different ways we can go about multiplying fractions. So I'll break it up into 2 different parts here. So notice we have 2 methods for multiplying fractions, direct multiplication and cross cancellation. They both use this rule, but they are slightly different because in direct multiplication, we multiply first and then reduce our answer. But in cross cancellation, you do any reducing first and then find your product. So let's do a few examples of each. Starting with example 1, where we'll use direct multiplication. To find the product of these fractions, I just have to multiply the numerators, 3 times 5, and divide that by the product of the denominators, 4 times 6. And then if I find these products, 3 times 5 is 15, and 4 times 6 is 24. But then this fraction, I have to check if it reduces. I'll check for what is the biggest number that divides evenly into both 15 and 24. And that number would be 3. So I could divide both the numerator and denominator by 3. And when doing that, I get my final reduced fraction. 15 divided by 3 is 5, and 24 divided by 3 is 8. Now let me show you how we could get this same answer of 5 over 8 using the method of cross cancellation. So I'll write this same example. Now when we did this example with direct multiplication, we did the multiplying first and then reduce the fraction. But what we could do instead is check for any factors that reduce before doing the multiplying. And when multiplying fractions, not only are we allowed to cancel factors within their own fraction, but we're also allowed to cross cancel. That means we're allowed to check if any of the factors in either of the numerators cancel out with any of the factors in either of the denominators. We're allowed to even look across between the 2 fractions. So for example, if I look at this factor of 3 that's in the numerator, and this factor of 6 that's in the denominator, I know that they have a greatest common factor of 3. So I could divide both of those numbers by 3 to simplify this product. 3 divided by 3 is 1, and 6 divided by 3 is 2. And now I can find the product by multiplying the numerators, 1 times 5, and dividing that by the product of the denominators, 4 times 2, which gives me 5 over 8, which notice is the exact same answer we got by doing direct multiplication. Let's do one more where we do both methods. In this example, we have a fraction times a whole number. It might be helpful if we rewrite that whole number as a fraction 8 over 1, which is equivalent to 8, right? Because 8 divided by 1 is 8. And then when using the method of direct multiplication, I know I can find my product by multiplying the numerators, 5 times 8, over the product of the denominators, 6 times 1. And that gives me 5 times 8 is 40. And 6 times 1 is 6. So I have 40 over 6, but that fraction can be simplified. It can be reduced. I know that 2 divides evenly into both 40 and 6. So I'll divide them both by 2, and that will give me my equivalent but reduced version of the final answer. 40 divided by 2 is 20, and 6 divided by 2 is 3. And then let's try this same example again, but this time let's use the method of cross cancellation. Once again, it may be helpful to write this whole number as a fraction over 1, and then we check are there any factors in the numerator that reduce with any of the factors in the denominator? Well, I know that 2 divides evenly into both 8 and 6, so I'll divide them both by 2. 8 divided by 2 is 4, and 6 divided by 2 is 3. And then I can find this product just by multiplying the numerators, 5 times 4, and dividing that by the product of the denominators, 3 times 1. And this gives me 5 times 4, which is 20, divided by 3 times 1, which is 3. Notice the same answer we got when we did direct multiplication. Must know number 4, dividing fractions. The rule for dividing fractions is that if you have the fraction a over b being divided by the fraction c over d, we can actually rewrite this as a product where we keep the first fraction the same, but then we change the division operation to multiplication, and we multiply by the reciprocal or the flip of the second fraction. So instead of c over d, if we flip it, it becomes d over c. So simply put, you keep the first fraction the same, change division to multiplication, and flip the second fraction. Keep, change, flip will help you remember how to divide fractions. And then after you've written it as a product of fractions, well, you know how to multiply fractions. You just multiply the numerators, a times d, and put that over the product of the denominators, b times c. Now let's practice that rule with 2 examples. Starting with example 1, whenever we're dividing 2 fractions, the first thing you can do is change it to a multiplication question. By keeping the first fraction the same, change division to multiplication, and do the reciprocal of the second fraction. That just means flip it. So instead of 5 over 8, if we flip it, it becomes 8 over 5. And now that it's a product of fractions, we can look to reduce in this step before multiplying, or we can multiply first and then reduce. I think what I'll do is do direct multiplication here. I'll do the multiplication first. To find this product, I know that I multiply the numerators, 3 times 8, which is 24, and divide that by the product of the denominators, 4 times 5, which is 20. And then this fraction reduces because I know that 4 divides evenly into both the numerator and denominator. So if I divide them both by 4, I would get 24 divided by 4 is 6, over 20 divided by 4 is 5. So my final reduced answer is 6 over 5. Let's see if we can do example 2. I have 2 over 7 divided by 4. It might be helpful whenever working with fractions, if you have a whole number, think of it as a whole number over 1. So I can change that 4 to 4 over 1. And then to evaluate this, the first thing we'll want to do is change it to a multiplication question. And to do that, I know that I keep the first fraction the same, change division to multiplication, and flip the second fraction. So instead of 4 over 1, it becomes 1 over 4. And then why don't I look to do my reducing before doing the multiplication this time? I notice that I can reduce this 2 over 4. 2 divides evenly into both of those numbers, so I could divide them both by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. So that 2 over 4 reduced to 1 over 2. And now I can do my multiplying. In the numerator, I have 1 times 1, which is 1, and that goes over the product of the denominators. 7 times 2 is 14. Must know number 5, adding and subtracting fractions. The first thing you have to know about adding or subtracting fractions is that you must convert each fraction to an equivalent fraction with a common denominator. And then once you've done that, the rule for adding or subtracting fractions with a common denominator would be that if you have the fraction a over b plus or minus the fraction c over b, notice these fractions have the same denominator, the denominators are both b, the sum or difference would be equal to a single fraction where you keep that common denominator of b, and then you add or subtract the numerators. So you'd have a plus or minus c. So let me show you how that rule works with a couple examples. In this example, we have 2 over 7 plus 1 over 7. Notice those fractions have a common denominator, which means to find the sum of those fractions, all I have to do is find the sum of the numerators, 2 plus 1, and put that over the common denominator of 7. So 2 plus 1 is 3, so this would equal 3 over 7. Let's try another example where we don't have common denominators. In this second example, we have 5 over 6 minus 1 over 3. The first thing you should notice is that the denominators are not the same. So before being able to subtract these fractions, we need to get a common denominator. And to choose a common denominator, it's best if we choose the lowest common multiple between 6 and 3. So if I were to list the multiples of 6 and the multiples of 3, I would notice that the smallest number in common between these lists is 6. So 6 would be the lowest common denominator between these two fractions. Also notice there's another number in common between these two lists, which is 18. And it's no coincidence that that is the product of the denominators. The product of the denominators would always be a common multiple of the two numbers, but it's not always the lowest common multiple. And it'll make your life easier if you choose the smallest number in common between these lists. So we will make our common denominator for these fractions. We'll make the common denominator 6. In this fraction, the denominator is already 6, but in this fraction, the denominator is 3. So to make that 3 be a 6, I would have to multiply it by 2. And in order to keep this fraction equivalent to 1/3, I would also have to multiply the numerator by 2. So really what's happening here, when we have that 1/3 multiplied by 2 top and bottom, I could rewrite it in a different format. I could write it as 1/3 times 2 over 2. Just to make it obvious to you that what we're doing is just multiplying by 2 divided by 2 is just 1. So we're just multiplying that 1/3 by 1, which is not changing its value. It's just writing it in an equivalent but different format. So I'll write it back the way I had it before, and now I'll start simplifying this. I have 5 over 6 minus 1 times 2 is 2, and 3 times 2 is 6. And now that I have a common denominator, I can subtract the fractions. And to subtract the fractions, I just have to subtract the numerators. 5 minus 2 is 3, and then keep the common denominator of 6. And then this fraction reduces. 3 divides evenly into both 3 and 6. So I'll divide the top and bottom of this fraction by 3, and that would equal 3 divided by 3 is 1, and 6 divided by 3 is 2. And let's try one more example where we have a whole number. In this example, we have 2 plus a quarter. When we have a whole number, such as 2, it would be useful to think of that as being a 2 over 1. And when adding fractions, we need a common denominator, and right now, they're not the same denominator. So I need to find a common denominator between the numbers 1 and 4. The lowest common multiple between 1 and 4 is the number 4. So I can make this denominator be a 4 by multiplying it by 4, and then to keep the fraction equivalent, I would also have to multiply the numerator by 4. And then this would equal, I have 2 times 4, which is 8, over 1 times 4, which is 4, plus 1 over 4. Now that I have a common denominator, I can get my answer just by adding the numerators. 8 plus 1 is 9, and putting that over my common denominator of 4. And that fraction doesn't reduce, so that's my final answer.